Hi student friends, good evening to all. AS Engineering Academy welcomes you. In previous session, already we completed preparation strategy of computer organization and architecture subject, especially for CSE branch. Here it is the continuation. Here today topic is important concepts. While solving a problem, any problem, what about the different concepts you have to remember here immediately. In this, where I have selected some questions. For solving those type of questions, which type of concepts are needed to remember, remember immediately. Here, those are nothing but very important questions. And we expect these type of questions in upcoming competitive exams, not only in GATE exams, any PSUs, IES, like that. Let us start. First of all, check the question. For solving this type of question, which type of concept is needed to remember here? First of all, question is like this. It is the question. 0 cross or 0x C1D00000 is represented in IEEE single precision format. Its decimal value is dash. It is NAT question. Numerical answer type question. For this, there is no negative marking. Already we know the same. It is nothing but IEEE single precision format. Immediately remember. What is IEEE single precision format? Size, all those things. In this, first of all, look here. Let it is IEEE single precision format. Size is 32-bit. In these 32-bit, MSB is reserved for representing sign of the data. Next 8 bits are reserved for representing biased exponent, also known as excess exponent. Next mantissa, here 1, here 8, here remaining 23 because total size is 32-bit. Okay. What about the amount to be biased here? In single precision, IEEE standard. 127 biasing amount. What is small e? True exponent. What is capital E? Biased exponent. Capital E is nothing but small e plus b. Okay. What about the value expression? Means how to find the decimal value for this? -1 whole power s. S is nothing but this bit into 1.m. This 1 bit is nothing but a hidden bit. What is m? Mantissa, also known as significant, also known as fraction, into 2 power capital E minus b, nothing but capital E minus b is nothing but small e. Okay. What is the size of exponent field here? 8-bit. Let exponent field is given like this. (8-bit) E0 to E7 means what is the procedure for finding the decimal value? 2 power 0, 2 power 1, 2 power 2, like that 2 power 7. E7 into 2 power 7 means finally sigma EI into 2 power I. I value ranges from 0 to 7. It is the procedure how to find its value. Okay, na? Now, in given data, if you observe the given data, 0x, it represents hexadecimal notation, means C1D00000. It is in hexadecimal notation. Convert the same thing into equivalent binary. Each hexadecimal digit requires 4 bit. while converting it into its respective binary. C means 1100, 10001, D 13, 1101, remaining all are zeros. What is the total size? 32 bits. Because it is single precision. In this, what this one tells, sign, already I gave explanation for this. Sign. Next, what about next 8 bits? 1, 2, 3, 4, 5, 6, 7, 8. Capital E. Already we discussed how to find the decimal value. 2 power 0, 2 power 1 like that. 2 power 0, 1, 2, 4, 8, 16, 32, 64, 128. Means capital E value is 131. Next, it is nothing but M. Now in this, expression value is nothing but minus 1 whole power S into 1 point. What is this one? Hidden bit. Hidden bit here. Next, what is M here? 1010. Here, what is the size of M? M size is nothing but 23 bit into 2 power. What is the amount to be biased? It is fixed in IEEE standards 127. In IEEE single precision, it is fixed. So here, small e is nothing but 131 minus 127, nothing but 4. I am going to explain easiest technique for finding the decimal value. When this exponent became 0, then not needed to consider this one. To get 0 here, you have to shift the decimal point to right for 4 bits. So minus 1 into whole power 1. Minus 1 whole power 1 is nothing but minus 1010.1, 1010.0000, nothing but 2 power 0. Then this value becomes 1. So final decimal value is minus 11010 point. Here not needed to consider this one. So it is in binary. What is decimal value for the same? 1, 2, 4, 8, 16. So finally minus 26. Our answer is minus 26. It is the value. Okay, na? In first chapter, computer arithmetic chapter, IEEE standards are very, very, very important. IEEE standards used for representing floating data. Now next one. Second topic is memory organization. Read question first. To solve these type of questions, which type of concept is needed to get remember immediately? In any competitive exam, solution doesn't matter. You should solve the question at shortest time, because each and every 1 minute time is important and mark also important. Only 0.5 mark or 1 mark decides our career in future. Next, the width of the physical address on a machine is 40 bits. Next, the width of the tag field in a 512 KB 8-way set associated cache is dash bits. What is physical address? Main memory address is also known as physical address. Simply it is nothing but PA. How many bits it has? 40. What is the size of cache memory? 512 KB. CM size means cache memory size is equal to 512 KB. Means 512 means 2 power 9. K means 2 power 10. Bytes means 2 power 19 bytes. Memory space is nothing but number of words into size of one word. When word size is not given, default word size is 1 byte. That's why here, what about 19 bit? Nothing but CA. CA means cache address. CA means cache address. Means number of bits required to select one of the what's in cache memory is 19 bit, nothing but CA 19 bit. What is a tag field size in Blackway set associative mapped cache? Tag field size in N-way set associative mapped cache. What is tag field size? Expression, you remember this? Nothing but PA minus CA. Only this one gives number of bits in direct mapped cache plus log n. What is n? Associativity. Here, what is the associativity he mentioned here? 8. That's why 40 minus 19 plus log 8 with base 2. Nothing but 21 plus 3, 24. So what about our answer? 24. Okay, next. Not only this, if it is direct mapped cache, what is tag field size? Tag field size, nothing but PA minus CA. PA minus CA, what is PA? Number of bits required for addressing a word from main memory. CA, number of bits required for addressing a word from cache memory. To utilize this expression, you should know one point clearly. Both cache memory and main memory sizes must be expressed in same units. Same units means if cache memory is expressed in number of bytes, if cache memory is expressed in number of bytes, main memory also should be expressed in number of bytes. If cache memory is expressed in number of words, main memory also should be expressed in number of words. Suppose if situation is like this, if cache memory is expressed in number of bytes and main memory is expressed in number of words and word size is not equal to 1 byte, then you should convert both of them. Both of them means both cache memory and main memory into same units, means into either bytes or in words. Then only this expression is applicable. Okay, not only this one, sometimes let number of blocks in cache, means cache memory, and main memory are given. Means in place of main memory address and cache memory address, let number of blocks in cache memory and main memory are given. Then what about the tag field size expression for this? Simple expression is there. Log MB by CL with base 2. What is MB? Number of blocks in main memory. What is CL? Number of lines in cache memory. One cache block is also known as one cache line. Okay, na? Next, one more concept. One more concept. If it is fully associative cache, in previous class already I have explained the importance of memory organization topic. We expect more number of questions in any competitive exam from memory organization only. That's why you should keep more concentration on memory organization. Fully associative cache, mapped cache. In this, what about physical address format? It is very, very, very important. It is physical address format, PA, physical address format. In this, only tag field size, tag and word offset. What is the expression for finding word offset? Log BW. What is BW? Number of words in a block. Number of words in a block. How you find the tag size? Tag size is nothing but PA minus log BW with the base 2. In this, set offset field is not required. Set offset field is not required in fully associative mapped cache. Okay? Now, look here. Next question, very, very, very important and energetic question. If the associativity of a processor cache is doubled, associativity of a processor cache is doubled, means generally N represents associativity. What is associativity? Number of blocks in a set. Now, associativity is doubled, means right now it is 2, means it is doubled, means it becomes 4. While keeping the capacity and block size unchanged, cache memory capacity is unchanged, block size also unchanged, only associativity is changed, means it is present associativity is 2, doubled means it becomes 4. Next, which one of the following is guaranteed to be not affected? Which factor is not affected? In this, while increasing the associativity, what happens? Number of sets will be reduced, means set offset field will be reduced. Look here. It is the physical address format for block set associative mapped cache. Now it is a tag. Now total size is nothing but physical address. Now it is set offset, means set address field. It is word offset. Here, according to the given information, what he told, associativity is doubled, means number of sets will be reduced, means set offset field will be reduced by 1. Why? When number of sets is reduced, what happens? Number of bits required to select one of the sets also reduced. Then automatically tag field size will be increased. Then tag comparator size also increased. Okay, but there is no change in the word offset field. Only these changes are occurred only here and here. Come here. What he asked in the question, which is not affected? Width of the tag comparator. No, because it is compulsory affected. It is compulsory affected. Why it is affected? Because tag field size will be increased. Automatically tag field comparator size also will be increased. Next, width of set index decoder, it also will be changed. Means when number of sets is reduced, size of the set offset decoder also reduced, because set offset decoder is used to select one of the sets. When associativity is increased, number of sets will be decreased, so also affected. Next, width of the way selection multiplexer. Here for n-way set associative mapped cache, size of multiplexer is n-way set associative mapped cache. Size of multiplexer required is n cross 1 multiplexer. If it is doubled, earlier it was 4, now it is 8, means 8 cross 1 multiplexer. Then what happens? Associativity is doubled. What happens? Size of the mux also affected. What about next one? Width of processor to main memory data bus, always it is unchanged, it is fixed. So correct answer is D only. Okay, next. Now look here, excellent question it is. Read question carefully first. First read the question carefully, take 2 minutes time, no problem. Understand the question, then only you can able to understand my explanation. A 64-word cache and 256-word main memories are partitioned into 16-word blocks. The tag information is shown below. Current values in the cache are like this. Block, tag, identify the correct statements with respect to the availability of the main memory words in the cache. He gave 4 options. It is also MCQ question. First read question carefully. Okay. What is MMW? MMW means number of words in main memory. How many? 256 means 2 power 8 means PA size is equal to 8 bit. PA physical address size, main memory address size. Next, what is CMW? Number of words in cache memory. 64 means 2 power 6. What is the type of mapping? In this, he did not mention type of mapping. Automatically default is nothing but a direct map. Indirect map. In direct mapped cache. What about the tag field size? Tag field size is nothing but, already we discussed PA minus CA. What is PA here? PA is nothing but 8 bit, CA is nothing but 6 bit, nothing but 2 bit. What is physical address size? 8 bit. In these 8 bits, it is physical address format, 8 bits, 2 bits are used for a tag. Next, what about next one? Indirect mapped cache. Physical address format is like this. Next one is nothing but block offset. Next one is nothing but word offset. What is block offset? In this, what is partitioned into 16 words blocks, means each block size is 16 words. How many bits are required for this? 4 bits. To select one of the 16 words, we require 4 bits because address range is from 4 zeros to 4 ones. Next, since total size is 8 bit, 2 bits and 4 bits, automatically it is 2 bit. What about middle field represents? Block offset, cache memory block offset means number of bits required to select one of the cache blocks. 2 bits are there, means 0, 0, 0, 1, 1, 0, 1, 1. 0, 0 represents CL0. CL means cache line, cache block. Next CL1, next CL2, next CL3. It is the format. Now, These are nothing but blocks, means CL0, CL1, CL2, CL3. Okay. What is the tag given for CL0 10, CL1 10, CL2 00, CL3 01? Arrange this information in physical address format, then you will get solution. For arranging that one, look here. First of all, what about first tag information for this? For block 0, 10 means 10 is tag for which one? CL00. In CL00, how many words are there? 16 means 4 don't cares. Next, what about next one? 10 for CL1 means again 10 for CL1 means 01. Again it is having 16 words. Next, what about next one? For CL2 00, here 00, CL2 means 10, 2 binary value, again 4 don't cares. Next, CL3 01, CL3 means for 1101, it is the physical address format. Here, what about this one? It tells CL, it tells tag respect to tag. For that, what about decimal value for these? Here, 1, 2, 4, 8, 16, 32, 64, 128. Now look here, it is nothing but the decimal value computation order. In this, you remember one more point. How many words are there in main memory? 256. 256 words means W02, W255. These words are available in main memory, where cache memory can accommodate space for only 64 in these 256. In question, what he asked, according to this information, from W0 to W255, which words are available? Which words are available in cache memory according to given information? For this, now look here. What about decimal value for this? It is, first one is nothing but minimum value all zeros, maximum value all ones, means 4 zeros to 4 ones. Now in this, minimum value 10, 00, 00, 00, 2, where 10, 00, 1111. What about decimal value for the same? Very simple and very clear. 1, 2, 4, 8, 16, 32, 64, 128 means W128 2. 128 plus 15, 143. These words are available. Later, what about next one? Come here. 10, 10, 01. Again 4 don't cares. Means 4 zeros to 4 ones. It is fixed. Now decimal value 1, 2, 4, 8. 1, 2, 4, 8, 16, 32, 64, 128 means 128 plus 16. W144 means word number 144 to W159 because 144 plus 15, 159. These words are available. Next, what about third information? 0, 0. Next, 1, 0. Starting address 4 zeros, ending address 4 ones. 0, 0, 1, 0. For this, what about decimal value? 1, 2, 4, 8, 16, 32 means word 32 to word 47 are available. Okay, next. What about next one? 01, 01, 01, next 11, 00002, 01, 11, 11, 11 for this 1, 2, 4, 8, 16, 32, 64 means 64 plus 32, 96 plus 16, W112, 2, W127. Out of 256 words from main memory, cache memory can accommodate only 64 words. What those are? According to given information, those words are nothing but, watch this. What about those words? Those words are nothing but, first of all, 32 to 47, W32 to W47. What about next one? 112 to 127, 128 to 143, 144 to 159 means W112 to W159. These words are available. Remaining words are not available in cache memory. Okay, check options once. It is MCQ multiple choice question. Only one correct answer should be there. Identify the correct statements with respect to the availability of the main memory words in the cache. What about first one? Words 50 and 132 are available in cache. Look here. 50 is not available. 132 is available. Because of this, because of 50, it is false. Not only this one, option D is also false because in option D also, he mentioned 50. Okay. What about option B? The words 150 and 132 are available. Look here. 132 is available here. 150 is also available here. That's why option B is correct. Why option C is wrong? The words 178 and 150 are available in the cache. 150 yes available. 178 not available. Look there. 178 is not available. Because of that reason, correct option is B only. Okay? Next. What about next question? Here it is also direct mapped cache. Read question. Size of cache memory is 8 KB. Direct mapped cache. Read back and organized as multiple blocks. Each of size 32 bytes. Means what is BW? 2 power 5 bytes. Number of bytes in a block is nothing but 2 power 5, 32 bytes. Next, the processor generates 32-bit address. PA is equal to 32-bit. Next, the cache controller maintains tag information for each cache block. Next, which type of writing technique it uses? Write back. That's why he mentioned valid bit, modified bit. As many bits as minimum needed to identify the memory block mapped in the cache. What is the total size of memory needed at the cache controller to store metadata, means tags, for the cache? He asked the total size of tag. In this one, since it is direct mapped cache, what about tag field size? Tag field size for each line, each cache line, nothing but tag PA minus CA. Along with this one, extra bits, what those are? Valid bit and modified bit. What is PA? PA here. PA is nothing but 32. What is CA? Size of cache memory is 8 KB. 8 K means 2 power 13, means 13. Means here it is nothing but 19 plus 1 means 21 bits. 21 bits are required for each cache line. What is total tag directory size? Number of bits required for one cache line into number of such type of cache lines. How many cache lines are there? You should find. How to find the number of cache lines? What about the cache memory size? 8 KB. 8 KB. Here, what CL tells number of cache lines? Number of cache lines is equal to cache memory size by one block size, means 2 power 5 bytes. Byte to byte get cancelled. It is nothing but 8K means 2 power 13 by 2 power 5 means 2 power 8 means 256. So how many bits are required here? Each cache line requires 21 bits. How many such type of cache lines are there? 256. Total tag directory is, total tag size is nothing but 21 into 256. Correct answer for this one is nothing but option D. Okay, next one more point. If question is changed like this, if it is not right back, right through, and these are not given, then answer should be 19 into 256, because for right through, these additional bits are not needed to consider. Only PA minus CA is sufficient for tag of each cache line. Now, come to secondary memories. It is a secondary memory topic. Let me complete all the important points. Let me complete most important points from all the topics. We completed first and second topics. It is nothing but third topic. An application loads 100 libraries at startup. Loading each library requires exactly one disk access. To load one library, one disk access is required. Seek time of the disk to a random location is given as 10 millisecond. What is seek time? T-seek, 10 millisecond. Next. Rotational speed of the disk is 6000 RPM. RPM, 6000. What is RPS? Rotations per second. Technically, revolutions per second. RPM by 60, nothing but 100. 6000 by 60, nothing but 100. What is one rotation time? Here, number of rotations per second is nothing but 100. 100 rotations require 1 second. What is one rotation time? One rotation time is nothing but 1 by 100 second is nothing but 0.01 second. Nothing but 10 millisecond. Okay. Now, if all 100 libraries are loaded from random locations on disk, how long time does it take to load all libraries? One more point he mentioned clearly. The time to transfer data from the disk block, once the head has been positioned at the start of the block, may be neglected. What does it mean? After positioning the head at the target sector, transfer time is not needed to consider. For this, look here. Time needed for one library access, how much time it is? Nothing but seek time plus rotational delay plus read or write time. It is the expression for any secondary memory access of a word or library. Now in this, if rotational time is not given, you should take average rotational time. Average rotation time is nothing but half rotation time. Already, what about the value we got for one rotation time, 10 millisecond? Then what is average rotation time, 5 millisecond? What is seek time, 10 millisecond? So, what about this one? According to given information, not needed to consider. Look here. The time to transfer data from disk block, once the head has been positioned at the start of the block, may be neglected, means it is 0, means 15 millisecond. For how many libraries? One library. How many such type of libraries are needed to load? 100. That's why. What about our answer? Answer is nothing but 100 into 15 millisecond, nothing but 1.5 second. Okay, next. Now, it is very, very, very important concept. Look here. Here, hard disk has 63 sectors per track, 10 platters, each with 2 recording surfaces and 1000 cylinders. The address of a sector is given as multiple CHS format, where C is the cylinder number, H is the surface number, and S is the sector number. Thus, the 0th sector is addressed as 000, first sector 001, and so on. He gave the address of a sector. He asked the final sector number, means those sectors are starting from S0 onwards. Okay. In this, he gave CHS format. What C tells? Cylinder number. H tells surface number. S tells sector number. What is the standard method for this? Given cylinder number into H into S. What C tells? Given cylinder number into H into S. What H tells? Number of surfaces into number of sectors in one track, plus given surface number into S plus given sector number. Now, in this, what is C here? Given C, nothing but 400 into, what is H? Number of surfaces. 10 platters are there. Each platter has 2 recording surfaces. That's why it becomes 20 into, what is S here? Number of sectors, 63. This one is completed, plus H. Already we computed H is equal to 20 into S means 63 plus. Okay, now what about here? Small correction is there. Look here. Watch this one. Here we completed this one. What about next one? H into S. What is H here? Given H value is 16 into, what about S? Number of sectors, how many is 63? Plus given sector number, what it is, 29. If you compute this one, what about our answer? Answer is like this. Let me check once. Here, 400 into 20 into 63 plus 63 into 16 plus 29, you get 505037. 505037. Okay. Here, I am going to explain the same once again. It is the given cylinder number, this one into H into S, and it is the given surface number into S here plus this one. What H tells? Number of surfaces. Here 10 platters, each with 2 surfaces means total number of surfaces is equal to 20. Next, total number of cylinders, how many? Total number of cylinders is equal to 1000. Next, it is not yes, it is H. It is H. Next, what about total number of sectors? Nothing but 63. Okay. Now look here. 4th chapter in absolute addressing mode. Absolute addressing mode is also known as memory direct addressing mode. In memory direct addressing mode, instruction supplies the effective address. In absolute addressing mode, it is also MCQ question. The operand is inside the instruction? No. It becomes immediate. Next. What about next one? The address of the operand is inside the instruction? Yes. It becomes correct answer for immediate addressing mode. Next. The register containing the address of the operand is specified in the instruction, means it is register indirect. Location of the operand is implicit, means it becomes correct answer when he asked for implicit addressing mode. For this, correct option is B. Okay. Next. Excellent question it is. Look here. To solve this type of question, read question once. Read question once. A machine has 32-bit architecture with 1 word long instruction. Word size is 32-bit. It has 64 registers, each of which is 32-bit long. Register size is 32 bits. Number of registers is 64. It needs to support 45 instructions, which have an immediate operand in addition to 2 register operands. Assuming that the immediate operand is an unsigned integer, the maximum value of the immediate operand is dash. In this, word size is 32-bit, number of registers is 64. Okay, size of the register is not needed to consider. Here he asked the maximum immediate operand to be loaded in the instruction. Now look here. For this, what about instruction format? Look here. Instruction format. What he mentioned, immediate operand. It is immediate operand. Next, 2 register operands. Means here Rx and Ry, 2 register operands. Operation is compulsory required for any instruction. What is the total size? 32-bit. In this, how many registers are there? 64. To select one of the 64, it requires 6 bits because log 64. Log 64. Here, how many? 6 bits. Here, 6 bits. What is operation? Here, how many instructions are there? 45. Means log 45. Instruction means operation. How many? 6. Means out of 32, 18 bits are consumed. Remaining number of bits is nothing but 14. He asked the maximum operand to be produced here. Is it signed or unsigned? It is unsigned. So what about the range of the data in unsigned? Nothing but range is 0 to 2 power 4 minus 1. It is minimum value and it is maximum value. So what about maximum value? 2 power 14 means, it is 2 power 14 means 16,384 because 2 power 4 into 2 power 10, 16 into 1024 minus 1. So correct answer is 16,383. It is numerical answer type question. Next. Watch this. A 4-stage pipeline has stage delays of 150, 120, 160. Pipeline organization question. 140 nanoseconds respectively. Interstage buffer delay is 5 nanoseconds. Nothing but latch delay. Registers used constant clock rate. The total time needed to process 1000 data items on this pipeline is dash for this. Look here. What about n value? Number of instructions or number of operations? 1000. What is k here? K means number of segments, 4. What about t segment? Means segment delay time. How to compute segment delay time? In these 4, longest delay is 160. Consider longest delay plus buffer register delay. What it is? 5 nanosecond. Nothing but 165 nanosecond. What about the total time needed? K plus n minus 1 into t segment. What is K? Number of segments. What is n? Number of instructions to be executed. So what is K here? 4 plus 999 into what it is? 165 nanosecond. Finally we get 165.5 microsecond. Correct option C. Similar type of question was given in 2021 GATE also. Next. Excellent concept it is. Consider the following process. NS stands for nanoseconds. Assume that the pipeline registers have 0 latency. Don't consider the latch delay. 4-stage pipeline with stage latencies 1, 2, 2, 1 means what is the T segment here? Longest delay in the, longest one in the given delays. What is longest delay? 2 nanoseconds. Next. 4-stage pipeline with stage latencies. Highest is 1.5. Next, third one. 5-stage pipeline. Highest is only 1 nanosecond. Next, fourth one. Highest is 1.1 nanosecond. Then what about the maximum clock frequency we can apply? 1 by time delay. In this, frequency and time period are inversely proportional. Because of that reason, time period is smaller for this. It permits longest clock frequency, nothing but 1 gigahertz. This one, approximately 0.9 gigahertz. In question, what he asked, which processor has the highest peak clock frequency? What it is? P3. Now, observe this question. One more question from pipeline. Consider an instruction pipeline with 4 stages, S1, S2, S3, and S4. Each with combinational circuit only. The pipeline registers are required between each stage and at the end of the last stage. Delays for the stages and the pipeline registers are given below. In this, watch the diagram carefully. S1 register, pipeline register, also known as buffer register. S2 respective register, S3, S4. What he asked, what is the approximate speed up of the pipeline in steady state under ideal conditions? Under ideal conditions means while executing large number of instructions. What is speed up expression here? Here. What is speed up? Tn by Tp. What is the Tn? Tn, non-pipeline time for executing one instruction. What is non-pipeline time here? While computing non-pipeline time, don't consider the pipeline restart delay, because in non-pipeline, only one segment will be busy and remaining all are idle. That's why sum of all delays, 5 plus 6 plus 11 plus 8 means total 30 nanoseconds. What is a TP? Pipeline time. You remember one thing? While executing large number of instructions, one segment time is sufficient to execute one instruction. Here, TP per one instruction, TN per one instruction is 30 nanosecond. What is TP per one instruction? One of the longest delays. How much it is? 11. And at the same time, 1 nanosecond for the register means 12 nanosecond. So what about speed up? 2.5. So pipeline processor is 2.5 times faster than non-pipeline processor. Next, come to sixth one, control unit design. Main difference between a CISC and RISC processor is /R that a RISC processor typically. What is a CISC? Complex instruction set computer. RISC, reduced instruction set computer. In this, he asked the characteristic with reference to RISC processor, has fewer instructions. Yes, maximum 30 to 40 number of instructions. So it is also correct. At the same time, it is MSQ question. Next, has fewer addressing modes. Yes, maximum 5 addressing modes. Has more number of registers. Yes, 75 to 100 processing registers. It is easy to implement using hardwired control unit. Yes, it uses hardwired. So what about correct options? A, B, C, and D, all. Next, horizontal microprogramming. Control unit design topic. Does not require use of signal decoders. Does not require use of signal decoder. Yes, because vertical programming requires this. Next, results in larger sized micro instruction than vertical microprogramming. Yes, because in a horizontal microprogrammed control word, 1 bit is required for one signal. That's why length is longer. Yes. What about next one? Uses 1 bit for each one control signal. Yes. Finally, what is correct answer? All of the above. So it is not MSQ, it is MCQ, because all of the above is there. So finally, correct answer is only D. Okay, next. Now look here. An instruction set of a processor has 125 signals, which can be divided into 5 groups of mutually exclusive signals as follows. These are the groups. How many bits can be saved by using vertical microprogram over horizontal microprogram? For this, look here. If it is horizontal and vertical, find the number of bits. If it is horizontal, 20, vertical, log 20, because if control word size is n bits, vertical requires n bits, horizontal requires n bits, not vertical. Vertical requires log n bits. That's why in this log 20 means approximately 5. For this 70, approximately 7 log 70. 2, 1, 10, log 10 means 4. 23, 5. Means what about the total number of bits required for horizontal? 125. Vertical, 12, 13, 13, 14, 17 plus 5, 22. So how many bits that can be saved if it uses vertical over horizontal? This one minus this one, 103. Next. Now, IO organization. In this, first let me explain this. Which of the following devices should get the highest priority in assigning interrupts? Interrupt means a sudden break in normal program execution. If more than one devices asked the processor services, processor gives highest priority for high-speed device and lowest priority for low-speed devices. Which one is serviced first? In these four, hard disk is faster. If hard disk is not there, floppy, processor gives highest priority for floppy disk when hard disk is not there, because hard disk is faster than printer, keyboard, floppy, like that. So for this question, correct answer is hard disk. Next, 2011 GATE question, excellent question it was. A computer handles several interrupt sources of which of the following are relevant for this question? First one, interrupt from CPU temperature sensor, raises interrupt if CPU temperature is too high. I think some students know, if we watch the cabinet of a desktop, motherboard is there, on motherboard processor is there, processor is covered with a cooling fan. What about the function of cooling fan? While executing a program, some of electrical energy is converted into heat energy. So cooling fan is used to reduce the temperature of the processor. If cooling fan is not there, what happens? There is a chance to get failure of the processor, because for each semiconductor device, certain temperature limit is there. Next, what is first situation? Interrupt from CPU temperature sensor, raises interrupt if CPU temperature is too high. Next, interrupt from mouse. Next, interrupt from keyboard, interrupt from hard disk. Which one of these will be handled at highest priority? In this, D is having highest priority because for processor, self-protection is very, very, very essential. Because of that reason, it gives highest priority for temperature sensor. If it is not there, then hard disk becomes correct answer. Watch this question, last question in this session. It also belongs to IO organization. First, understand the question. Size of the data count register of a DMA controller is 16 bits. Processor needs to transfer file of 29,154 kilobytes from disk to main memory. The memory is byte addressable, means each memory location is used to store only 1 byte. The minimum number of times the DMA controller needs to get the control of the system bus from the processor to transfer the file from the disk to main memory is dash. If you are clear in one point, it becomes very easy to solve this type of questions. And I am a big fan for this question because excellent question it is. 2015 GATE question it was. Here in DMA controller, one terminal count register is there. TCR, terminal count register, size is 16 bit. 16 bit. After transferring 1 byte of data, terminal count register content is automatically decremented. When terminal count register is filled with all ones, then maximum size of data to be transferred is equal to, since TCR size is 16 bit, 2 power 16 bytes, because it is byte addressable memory, nothing but 64 kilobyte, means one request transfers 64 KB. What is the total size of the file needed to transfer? 29,154. Therefore, number of requests needed is equal to what is total size? 29,154 kilobyte. It is total size. For one request, it can transfer 64 KB. To get this, use calculator. 29,154 divided by 64. So answer is, we got 455.53 something, means number of requests required is 455 point something, means number of requests should be in integer only, nothing but 456. Answer is 456. You should remember one point. Size of the terminal count register, data count register is nothing but terminal count register, 16-bit. One request transfers 2 power 16 bytes, means 64 kilobyte. Size of the data to be transferred is this. So number of requests made by the processor is nothing, made by the DMA controller to the processor is target size of the data by one request size. One request transfers 64 KB. We get 456. 456. Okay, thank you very much.
Myself Abhishek Kumar Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now I divide my preparation strategy into 3 basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you. Myself Abhishek Kumar Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now I divide my preparation strategy into 3 basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing aspirant has to do is to solve as many test series as possible. I made 2 to 3 pages short notes of each and every subject. Now 2 to 3 pages short notes help in quick revision. If you keep working hard, you will definitely get success in this examination. This is what I followed, and I wish all the best for all the future aspirants. Thank you. Myself Abhishek Kumar Sharma. I have scored All India Rank 1 in UPSC Engineering Services Examination 2021 in Electrical Engineering discipline. Now I divide my preparation strategy into 3 basic things. The first thing is that you have to complete your syllabus from a basic standard source. The second thing is that you have to attempt previous year question. The third thing